Welcome to Algebra 2, Section 1.1 by your very favorite math teacher. Hey, did you guys hear about the two maggots who were fighting in dead earnest? So, ask your dad if you don't understand. We are going to start with Section 1.1 in our book. We're using Bob Jones, and this is called Real Numbers. A lot of our first chapter is going to be a review of things that we did last year in Algebra 1, but it's going to take it at a much faster pace. It's going to take it and add little bits and pieces. So hang in there, hold on for the ride, and let's see what we can do. So let's go ahead and work backwards with the types of numbers, definitions of numbers that we have. First we have natural numbers. These are natural numbers. And natural numbers can be expressed just by using an n. Natural numbers are the numbers that we learn to count with. When we start counting, when we were really little, we didn't start saying 0, 1/2, 3/4, 1. We started 1, 2, 3. So the natural numbers, they're the set of numbers where we start with a 1, 2, and 3. They don't have 0. They don't have any negative numbers in them. That's what the natural numbers are. And then, included in the natural numbers are included in a set of numbers that's a little bit bigger. And these are the whole numbers. And we can say that W represents the set of whole numbers. I'm going to go ahead and use some different colors here. With the whole numbers, we added an extra number to the natural numbers that we had. The natural numbers, I just said, were our counting numbers, starting with 1, 2, 3. And we learned that when we ran out of jelly beans, we didn't have any jelly beans left, and that there was a number for that, and that was 0. So it was 0, 1, 2, 3, and so forth. So the whole numbers can, a smaller subset of that is the natural numbers. The natural numbers plus 0 gives us the whole numbers. Now we have the integers. We're getting a bigger set of numbers, and integers is what we worked with on the number line. We have our little number line here, we have 0, we have positive numbers, and then we have negative numbers. So what we do with integers is that we've added the opposite of all of the whole numbers except for 0. 0 doesn't have an opposite. But when we talked about opposite numbers are those that are the same distance from 0 in opposite directions. 2 is 2 units from 0 in the positive direction to the right. Negative 2 is 2 units from 0 in the negative direction, but the distance between them is the same. So, the integers, which I believe they're still using as an I, well, it used to be I, now they represent the set of integers with a Z. Now, I wasn't interested enough to research why they're using a Z, but that's a strange thing to do. The set of integers is sort of like the negative counting numbers, negative 2, negative 1, 0, 1, 2. Can you hear my chicken out there clucking in the garage? What the integers are is the set of whole numbers plus the opposites of the natural numbers. So you have all of these integers, then you break it down. A smaller portion of those integers is the whole numbers. Then you remove 0, and you have yet a smaller group of number, and those are the natural numbers. The next set of numbers that we have is called the rational numbers. Rational numbers are numbers that can be written as a ratio or as a fraction. The number 2/3 can be written as a fraction, 2/3. 0.5 can be written as a fraction. 0.5 is 5/10. You can write that as 1/2. So rational numbers are the set Q. And we have an interesting little definition that I'm going to copy down here for you. Rational numbers is a set Q, and this says that that is the set of all P divided by Q such that P and Q are elements of the integers. Q is different from 0. Now you look at that, kids. I know my kids. You look at this and you think, oh my goodness gracious, that is the biggest bunch of gobbledygook I've seen, and it's already only the first day of Algebra 2. But what this says is that the rational numbers, this whole big set of rational numbers, we're going to use a Q to represent all of that. And what rational numbers are things that you can write as a fraction. The numerator, which is P, and the denominator, which is Q, both of those have to be integers. In other words, it's 7/-2. That's a rational number because those are integers. However, 0.73 divided by 2.5, that's not a rational number because the numerator isn't an integer, the denominator is not an integer. So that's all this is saying. Rational numbers are defined by the number Q. It's that set they're identifying as Q. You have to be able to write them in rational form. Is that a rational number? Yes. The number 4 is rational because it's possible to write that in the form of a fraction. 4 divided by 1 is equal to 4. Now, do we usually write it like that? No, of course not. But it's still a rational number. And Q can't be equal to 0. Remember, it's not possible to divide anything by 0. Let's just say 4 divided by 0. If we tried to put 4 times 0 is what? 0. Anything times 0 is equal to 0. So it is not possible, it's illegal, to divide by 0. So rational numbers are things that you can write so that they look like a fraction as long as the denominator is not equal to 0. That's all that we're saying here. And then we have, this will break up a little bit now. This is different. We have real numbers. Real numbers can be either rational numbers, my board's not big enough, or they can be irrational numbers. Irrational numbers are numbers that you can't, they don't terminate, they don't repeat. They're usually roots. Example, irrational numbers, they are non-terminating, non-repeating decimals. Non-terminating, non-repeating decimals. Most frequently they're non-perfect roots. And then we have an extra set that I've told you we would be coming to, and these are complex. Last year I said that we had imaginary numbers and that we'd work on them in Algebra 2. Imaginary numbers. Imaginary numbers we're going to work with in Chapter 8. So we've got a good ways to go. These are just the various ways that we break down our number system. You need to be able to understand what all of those. You need to remember that subtraction is the same as adding the opposite Another thing that you need to remember is that to divide by a number is the same as multiplying by the reciprocal. And the way that they say this abstractly is they say that if you're going to divide this number, x divided by y, that that's the same as taking the numerator and multiplying it by the reciprocal of the denominator. And that's really nice when you solve problems like 4/3 x is equal to 21/5. If we wanted to isolate our variable, we're going to multiply by the reciprocal of 4/3, 3/4 times 4/3. Multiply both sides by the reciprocal. Cancel common factors. X is equal to whatever this product is here. So that's why division by a reciprocal is particularly valuable. Let me walk up here and check how much time I have left. It doesn't tell me. We have our properties that you remember for multiplication and addition. The commutative property says it doesn't matter in what order or you add or multiply. 5 times 2 is the same as 2 times 5. 5 plus 2 is the same as 2 plus 5. They're commutative. Associative, remember the associative property says it doesn't matter what order you group when you're multiplying or dividing, you will get the same value. A plus the quantity b plus c is the same as the quantity a plus b plus c. We can first multiply together b and c, or a and b. What that says is this lets you group conveniently. If you have 15 plus 23 plus 2 plus 85, and you're doing rapid mental math, 15 plus 85 is 125. It just lets you do things more conveniently. That's the associative property. Let's see, we have identity, inverse, closure. Okay, the identity, if you add nothing to something, you don't change the value, do you? If you multiply something by 1, you don't change the value. This is called the additive identity. Add 0 to something, you don't change its value. The multiplicative identity, you multiply something by 0. By 1. I'm sorry. Additive identity, multiplicative. Okay, multiplicative identity. Don't change these values. Inverse, if you add two opposites together, you always get 0. Whatever it is, when you add its opposite, you always get 0. Whatever it is, you add its opposite, you always get 0. It's the inverse property. And then we have distributive property of multiplication over addition. Distributive property is essential to remember. And this is particularly a bugaboo when you're working with negative numbers, with negative signs. You'll remember that from last year. But this says if you are multiplying something against a product, a times the quantity b plus c, but that's equal to ab plus ac. What that says is that if you have 4 times x plus 2y, that's going to be equal to, this is our a. A is equal to 4, b is equal to x, c is equal to 2y. Remember how we substituted? So this here becomes 4 times x plus 4 times 2y. 4x plus 8y. Be really, really, really careful when you have a negative sign. Remember, if you are multiplying by a negative number, the sign of each term inside changes. Negative 2 times a positive x, that positive becomes a negative. Negative 2x, negative times negative gives us a positive 4. Look at that. Think about what I did. This is something we beat to death in Algebra 1. Get with me if you need some help on it. The last property that we want to mention that is new to us this year, this is called the closure property. And frankly, I don't remember the closure property being used. I think it's just something that we understand, but they have a name for it. So let's talk about it for a minute. We have the closure property. It says that